Okay, great. So, continuous integration for Jakarta EE applications. My name is Lukman, and I'm the technical writer for Pyara. It's great to see all these great talks ahead of me, put things in context for this particular talk. So, continuous integration for Jakarta EE applications. Now, following in the footsteps of the legendary Adam Bean, I created a very lean set of slides. So let's start with our first slide, continuous integration or continuous development for Jakarta EE applications. We're going to look at the what, the how, and then finally we dive into the action. So continuous integration, what exactly is it, first of all? Now, to understand continuous integration within the context of Jakarta EE, let's step back and actually ask, what is Jakarta EE? Since the beginning, since the J2EE days, Jakarta EE has always been a platform that abstracts you from its runtime. So you have a set of specifications that you can use to develop whatever application you want to develop, solve whatever business domain problem you have, and then deliver value to your customers. And the actual runtime is always separated from the specifications that you are using. This has always been Jakarta EE, and this has always been how it is. Now, most of the time, we talk about Jakarta EE in isolation. But then when you develop your application in your company or in your spare time, your hobby app, whatever it is you use Jakarta EE for, between the code that you write and the final end users, there is a series of intermediate steps. And I like to liken these intermediate steps to a factory conveyor belt, as you can see on the slide. So think of your Jakarta EE code, your application, your shiny, spanking application as the factory that produces the base product. Now, for that product, your finished product, which is your application, to get to the end user, it has to go through a series of steps. And in terms of code, in terms of continuous integration, this series of steps can be testing, it could be building the application, it could be some quality control. It depends on the business domain. Traditionally, it has been setting up pipelines to test the application. Now, the good thing with Jakarta EE is that it fully separates your business code from all these intermediate steps. So you can have your code, your product, work on this conveyor belt without being tied to the conveyor belt. And that is the power of the Jakarta EE abstractions that has been the norm since the beginning, since the J2EE days. So you are abstracted from this particular conveyor belt. So your code moves from your developers, your computer, wherever you develop your code, goes through this conveyor belt and then gets to the end user. So think of the end user as the final consumer of whatever you're producing. So between your code and the end user is our continuous integration. And this series of steps or this conveyor belt is what we are going to talk about. So in essence, continuous integration for Jakarta EE applications is essentially you creating a conveyor belt to convey the application that you have written to your end users. And because Jakarta EE gives you all the flexibility to not tie you to any specific paradigm, you are free to pick any conveyor belt, again, or continuous integration system that you will to deliver that value to your customers. So in essence, Jakarta EE gives you that flexibility to pick. And traditionally, there has been many continuous integration options out there for different permutations of applications. There is the much more traditional one, the much more heavyweight, the much more battle-tested, the known ones like the venerable Jenkins. And then there is the much more Tesla-like guys. You have the GitHub pipelines, GitHub actions. These new paradigms are all continuous integrations, or again, if you are using analogies, they are all modern conveyor belts that you can put your Jakarta EE application on, pass it through whatever specific intermediate steps that your context needs, and then pass through that and then get it to the end user. So we are going to see 3 examples of these permutations. We are going to see deploying through the vulnerable Jenkins, and then we are going to see, and through Jenkins, we are going to deploy from Jenkins, run our test, and then push our application packaged as a Docker image to Docker Hub. And then we're going to see using the much more modern, much more Tesla-like new ones, GitHub Actions. So we're going to see using GitHub Action to also build our application and then push to Docker Hub and also to a specific Jakarta EE runtime. Most of the time, your application is going to be delivered to the end users in different ways. For some companies, you will have the application packaged as Docker containers and then deployed to custom runtimes. The runtimes could be anything. It could be any of the options out there, Payara, OpenLiberty, Glassfish. It could be anything. Or it could be any kind of Jakarta EE runtime like Amazon Beanstalk or Payara Cloud or any other options out there. So those are the options we have for taking your application, passing it through those intermediate steps, or again, the conveyor belt to the customer. So let's go to the IDE and then look at our sample application. For starters, we have a very generic Jakarta EE application. And by generic, I mean pure Jakarta EE, of course, using third-party libraries for parts that don't come as part of the platform. So we are using the open API, the API in our application. And our application simply talks to OpenAI's ChatGPT. So we take prompts from the user and then go to ChatGPT for responses and then display that to the user. Of course, you might be wondering, what can I? Why would I want to? It's just a display. We are going to see drawing images from the ChatGPT API when we deploy the application. So it's a fairly vanilla Jakarta EE application. And this particular service here, this controller service here, is a singleton that takes care of all the interactions with the OpenAI API. We're not going to delve into this. This is not what we're interested in. Let's come to our first descriptor here. So this is our first Tesla-like descriptor, our Tesla-like conveyor belt to take our application from our code, run it through the series of steps, and then push it to Docker. So let's go walk through what this descriptor is, this configuration file is doing. We are simply saying when we push to this branch or a pull request is open to this branch, then run this particular configuration, this particular GitHub action. Now we have our secret setup. Our Docker username is set up as a secret configured on GitHub. And then we are simply tagging our container here. We are setting the image here, which will be used to name the image. And subsequently, when you run the container, that's what you're going to use. And everything else here is something you can literally read from top to bottom as a book. The good thing is that all of these things here have nothing doing with Jakarta EE. There's nothing Jakarta EE specific here. The most interesting parts are here where we build the image and then push to Docker. These are the two interesting parts. The rest are very vanilla, very simple Maven workflows. We package the application, run the test, and only build the image when the test succeeds. So this is very simple. The power here is that our application is completely isolated from this particular conveyor belt construction. It has nothing to do with it. This could as well have been a Java SE application the conveyor belt really doesn't care because everything is separated. So with this descriptor here, our application is going to be run on a pipeline in GitHub Actions, tested, and then if everything works out, then gets pushed to our Docker repository. Now, the next one is our vulnerable Jenkins here. Now, for this particular Jenkins setup, I am actually running Jenkins on my machine, not deployed to any server. The idea is to create an infrastructure as code sample so that for the other developers that will be interested in it, you can just pull it and run it on your machine. So Jenkins is actually running locally on my machine. And with this descriptor is configured to actually listen to the repository for this particular application. So when there is a push in there, the Jenkins on my machine is configured to listen to the webhook and then start running the pipeline. And this pipeline, again, is pretty much vanilla with nothing Jakarta EE specific. It's generally as simple as you can get. What we are doing here is running Maven in batch mode, and then also avoiding all the logs with the non-transfer command here, the directive here, telling it to not print all those logs, downloading blah, 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 to not print all of those things. So pretty much vanilla Jenkins pipeline here. The interesting part of this is that this Jenkins is running locally. So if I come here, you should be able to, maybe let me just expand this as well. Appearance, presentation mode here, so you can see it well. There's really nothing specific Jakarta EE here, just vanilla Jenkins. And so this here is going to go to GitHub, and then our configured Jenkins locally is going to look at this, listen to the webhook, and then start running the pipeline. And the interesting part for this configuration, again, is this line where we simply take the build container here and then push it to our configured Docker repository here. Again, we are using Jenkins credentials to store our credentials. Security practice, you absolutely should not expose credentials anywhere in anything you are pushing to your source code management system. So we are using the secrets that Jenkins provides, the credentials feature that Jenkins provides to set the GitHub username and password. And then we are grabbing those in here to use to authenticate to Docker Hub here. And then once everything works out, we come down here and then push the built image. So this image here is actually configured at the top here. This is the image name. Of course, this is just for demo purposes. You could, in practice, you would want to set this dynamically so that you don't have to re-tag or rebuild or edit this particular Jenkins file to set the version for each released image. But for our purposes here, this should work out just fine. So we have our Jenkins file set up, and our Jenkins is running locally. So if I, for a second, exit our presentation mode, you can see our Jenkins running in a container on my machine locally here. So this is our second look at the conveyor belt configuration or the continuous integration pipeline configuration. First one, we've looked at a Tesla, GitHub Actions, and then our vulnerable Jenkins here. And then the third option here is, again, GitHub Actions, but this time around, instead of pushing or packaging our application as containers and pushing to Docker Hub, what we are doing here is packaging our application as a WAR file and then uploading to a Jakarta EE runtime. So this here, again, pretty much similar to the Docker setup here, except for where we actually push the end product, where we actually serve the end product that we wrote. In this case, we are pushing those to the Jakarta EE runtime directly to be able to run it for the user. So we are pushing those to Pyra Cloud here. Now, again, all these three configuration files that we are looking at here, there is really nothing telling you that this is Jakarta EE. These configurations are being used for Jakarta EE. There's really nothing telling you about that. And that is the power of Jakarta EE, because it isolates you, or it abstracts your application from underlying infrastructure. So this conveyor belt example that I've been citing is an infrastructure issue. You don't have to, your code, your business context, the value that you want to deliver to your customers should not be mixed with the means of delivering that value to the customers. Once you mix the two, then you begin to have a lot of complex code that becomes very difficult as time goes on to extricate different parts of, especially when you need to debug things. And the Jakarta EE helps you stay clear or steer clear of those problems. So you have our code. As you can see, we have our application here. If I open this, this is a vanilla Jakarta EE application with our logic and everything going to the ChatGPT API, getting our response and doing stuff with it so that we can show it on the UI. And then in terms of delivering that, we have our configurations here. So those are our three options. Now, as developers, we are always itching to see things in action. So let's just make a small change somewhere. Let me just open our test and say GPT test. And then let's just change something here. Let's call this guy test country. Make a change, and then let's try and make a commit here so we can push this. Then call this update test variable. This will be a moment of truth. So commit, continue, yes, commit. And now let's push this here, push. And so this should be pushed. Now let me bring in the actual GitHub repo. So this is our GitHub repository here that I just made a push to. Now, if I refresh this, should show my push. So now my pipelines are running. So let me go to my actions here and then check. So you can see the two actions that I have are the ones running. So if I come back to the IDE, in my GitHub workflows directory here, I have two GitHub actions descriptors here. So move from push to Docker and then push to PyraCloud. Now, GitHub actions is very powerful in the sense that you can have different configurations for practically different purposes in your application. So for instance, you can have a set of microservices where you have to push to different repositories or even to different package places or different Docker repositories or whatever. GitHub Actions allows you to do that. And that is what we are simulating here with these different GitHub Actions configurations here. So this should push to Docker, and this particular one should push to PyraCloud. And then also we have our Jenkins here, which of course, Jenkins is always Jenkins. So we have our Jenkins file here, which will sit here and then trigger things for our Jenkins running locally. So let's go back here and then come back to here, refresh. Okay, open this, nope, pipeline, open this, nope, here, branches, and then just run this. And then this should also run here. Now, if you go back to here, you can see our GitHub Actions is complete. So update test variable, this is the commit I just made. So this one should complete and be done with what it's doing. So here, build and push, everything is done here. And then if we come back here, this should also be done. So we should have these two done. Now, let's confirm this. Let's first go here and then check. If I come here, I should have something in my repository if all worked well. Yes, all worked well. And then I have something in my repository, my Docker Hub repository. So here you can see last pushed 2 minutes ago. And so my image has been pushed to Docker Hub right from my GitHub actions. So this here, if I come back to the IDE, my Docker configuration here is working as expected. So my image has been pushed, and this is the image name, the repository name, and then this particular, the image name and the tag here have all been pushed. And so we can confirm that here's a Lookman Fish, Jakarta EE. And then if you go to tags, you should see our tag 0.1, 0.0.1 here. We have our tag here. So this is working as expected. In the meanwhile, we can also check out our Jenkins guy here. So our Jenkins has also run through and it's now pushing to Docker. And hopefully, yep, this has also completed and has pushed our image to Docker. Again, this is running locally. So this is actually running completely as infrastructure as code. So you can just pull it from your repository or from the sample repository and then run it on your machine without needing to set up any server whatsoever. So this is also done, and this has pushed to my Docker account here. So if I come here, I shall refresh this, or better still, go to my repositories. Here, now you can see I have two images here. There is JEE, GPT, Jenkins here, and this is coming from the Docker, the Jenkins configuration we did here. This is the image name that we set. JEE, GPT, Jenkins here. We have this set up. And this is exactly what has been pushed for us. So to recap what we've discussed so far, continuous integration is a means, it's an intermediate means of getting your application from wherever you're developing it, your machine, the office, a set of developers, wherever, to the final end users. Now, this intermediate set of actions is completely separated from your Jakarta EE application, or better still, should be separated from your actual business code. And as you can see in our demo so far, our application has nothing to do with that intermediate set of steps. The intermediate steps are used or are created as descriptors, as declarative language requirement. We just declaratively set things, and then it is doing things on our application. So we have this clear separation of concerns. Now let's go back to the browser. So we have this pushed, our images are pushed. Jenkins is green for us. Then if we go to our pipeline, our GitHub actions, both of our descriptors, both of our actions are green. Now let's also go to the final endpoint here and then check if it has been pushed for us. Now, if we come here, you can see our application has been pushed. So this is our application here that has been pushed for us. On my time, it is here. This is it. This is when it was pushed, December 6th right now, when it was pushed. So this is pushed for us. Now let's configure this guy here, edit configuration here. This is our application. Now, if we go back here, this is our application, and these are the configurations that we have. Now, to actually be able to use the application, we need to pass our key, our OpenAI API key. Now, again, we really don't want to, again, you shouldn't. Security practice, you absolutely should not show or check in your API keys as part of your version control. You absolutely shouldn't do that. So there should be a way you can configure your GitHub, sorry, your secret keys. So in GitHub, for instance, we set it as part of our GitHub secret. So if I go to settings and I go to secrets, actions, here, you can see my OpenAI key is set as part of the secret here. And then for the images, for the Docker image here, what we are doing is that in the Docker file here, we are actually getting this and then setting this here. Even this is a problem because now our image is public. So somebody pulls our image, they have access to our key. Now this is here, assuming the image is being pushed to a private repository. For demo purposes, I just push to a public repository. But if you are doing this, then you shouldn't push to a public repository. It should be to a private repository. Or you should have a way of making the key available when you run the container from the image. So just keep that in mind. So for our containers, we have these key sets for the images that are built from this Docker file. And so we need to configure this as well for our runtime. So let's go back here and then configure this. Let's add a key and then call this OpenAI key. And then simply paste in our key, copy from the other screen, and then paste this in, and then save. And once this is saved, we can now deploy our application here. Whilst this is deploying, we can go back to our code and then run through, again, what we've discussed. This Jakarta EE application, we want to serve it to our customers, our clients, our users, doesn't really matter. And we need to pass it through the series of pipelines or series of steps. And this series of steps, as we discussed, is much akin to a conveyor belt in a factory, sorry. So this conveyor belt takes items from one step, passes through the next, passes through the next, passes through the next, and then ends up at a certain point. Now, the conveyor belt really doesn't know about what it's carrying, and what is being carried doesn't know about the conveyor belt. And that's exactly what we have done here with our code. So we configured our conveyor belt or our pipelines to take our packaged application, do a series of things on it, and then drop where. And that somewhere is where we are so far. So let's go back here. Our application is deployed. Now let's take it for a spin. Okay, so let's generate an image. Hopefully this works. And a gathering of Java developers for a conference. Let's see what we get. Hopefully this works. Okay, so we got some image. Okay, it's okay. It's workable. It's okay. Yeah, so our application is deployed and we have a response from, we have a response from OpenAI for our deployed application. I don't have any questions so far. So to recap everything, because as with everything about Jakarta EE, there is almost always so little to say because it just works, and it works so well because your actual application domain, the part that concerns you, where you are adding value, it's so small because the platform isolates you from a lot of underlying stuff. You don't really need to know how your application server works. If you download Pyara, you don't really need to know how it works. If you download OpenLiberty, you just need to know how to start it, and then you deploy your actual application on it. Of course, this whole rigmarole may not necessarily concern you if you work in an organization that has a whole DevOps team that takes care of these things. But as the developer, it's good to know these intermediate steps or this series of steps that your application goes through. So because Jakarta EE doesn't bind you to any specific paradigm, any specific edict, any specific way of doing things, you are free to pick whatever works for you. And in this day and age, there are many options to create pipelines. And Jakarta EE simply works with all of them. It just works with all of them, from the venerable, battle-tested Jenkins to much newer paradigms like GitHub Actions. As we've seen, it works for every single one of them. So if we come back to our GitHub Actions here, we go to our actions. All these runs that we have are for the application, but there is nothing Jakarta EE specific about them, because Jakarta EE originally from the start has always been designed to be a step above whatever underlying infrastructure you need to run your application on. And this is an example of that, the benefits of those abstractions. So our application is now being tested on GitHub using GitHub Actions nearly for free without lifting a finger. We just need to put in a few descriptions in the GitHub Actions descriptor, and then we are done. And that is the power of Jakarta EE. So setting up pipelines for Jakarta EE is as simple as picking one, describing whatever you want, and then set the ball rolling. Is there any question for me? Let me check in the chat. Okay, so there's no questions so far. So in the absence of any questions, then since Jakarta EE is so simple and so straightforward, we are done. There's really not much to say. Our pipelines are running. Everything is green. Here, it's green. And here, everything is green. Our applications are pushed to our repositories and deployed here. And so we are good. And not a single one of these saw Jakarta EE tied to whatever underlying magic or infrastructure we set up. And that is the beauty of Jakarta EE. In the absence of any question, I will just hand over to the host to continue this our awesome gathering of Jakarta EE today in this conference. Thank you very much.